next, what I'm gonna go ahead and do is demo some of the important parts of the experiment and setup, just so you feel a little bit confident moving forward. So the first thing that we're gonna do in order to do this experiment is we are going to be prepping a sodium chloride solution. Now, the reason that we're doing this is because one of the reactions that we're gonna be looking at in terms of LeChatelier's principle can be affected by the addition of sodium chloride. So we need to make this sodium chloride solution to use throughout the experiment. So let me show you what you're gonna do here. So what you're gonna do is you're gonna take your pocket scale and you're gonna tear your weigh boat on there and you're gonna weigh out 4.5 grams of sodium chloride. I've already done that here. So here's my 4.5 grams. One thing I recommend is because this salt is coming from your own house, if you weigh out more than 4.5 grams, don't put it back into your salt container. We don't want any contamination. What I would do is if you have extra, you can just pour it out into the trash until you get the proper mass, okay? Now, what you're gonna do is you're gonna take that salt that you weighed out and you're gonna add it to your 25 ml Erlenmeyer flask, okay? Now, it's a pretty significant amount of salt, so it's gonna look a little intimidating. But what you're gonna do now is you're going to add the 15 mils of water here, okay? So let me show you how we would do that. All right, so the 25 milliliter Erlenmeyer flask is gonna look like this. Now, in my experience, I have had students in the past that did not have this 25 ml Erlenmeyer flask. It does happen sometimes. If that's you, don't panic. We can replace this with a plastic cup for this particular experiment. The reason is because we're gonna be making a saltwater solution in this flask. It is doable in a plastic cup. So again, preferably we wanna use this 25 ml Erlenmeyer flask. If you don't have one, a cup works just as well. So again, we're gonna put that in our equipment pile. Don't pile it, right? Equipment center is probably a better way to say it. All right, we're also gonna need a plastic spoon. So this will be included in your equipment kit as well, so plastic spoon. You're also going to need your test tube rack. Now, if you remember, the test tube rack is cardboard, so it looks a little like this. It's got this little fold out insert that we're gonna use, and I just pop that back into the box, and that's gonna kind of help hold everything up. So we've got our test tube rack. We also are going to need our test tubes for this particular experiment. So the test tubes should also be in this equipment kit here. So you'll find them with the droppers. So the test tubes look like this. We need 5 of them. And we're gonna go ahead and just slot those into our test tube rack. So 1, 2, 3, 4, 5 test tubes. Okay, that's 4. I know how to count. 5 test tubes. There we go. Okay, putting that into our test tube rack. Next up, we're gonna need a dropping pipette. So that's one of these plastic guys right here. We're gonna put that with our equipment. We're also going to need a plastic cup. I already pulled that out, but like I said, pull out a second, doesn't hurt. And then we need the 10 ml graduated cylinder. So the 10 ml graduated cylinder is the smaller of the two. You'll see that in your equipment kit, excuse me, you have 2 large graduated cylinders. This is the 50 ml, we want the 10 ml. 10 ml graduated cylinder. And then the last thing we want is our grease pencil, which we're gonna use to label our test tubes. All right, so that is everything that's provided in the actual lab kit. So you'll see I have all of my equipment laid out, I have my chemicals laid out. Now, one of the things that you're gonna need that is not provided in the equipment kit is table salt, so sodium chloride. So you wanna grab some of that from your kitchen. You're also gonna need some filtered water. You can either use bottled water or the water from your kitchen. And I'm gonna put that on my chemical tray. So this is all of our equipment laid out. We are going to move on to our next video in which I will describe sort of the setup and how to observe your results and also how to clean up your setup with proper safety as well. So to add the 15 mils water, what you're gonna do is you're gonna take your 10 mil graduated cylinder, your bottled water. You are going to measure out the maximum volume here, which is 10. So you're gonna pour till you have 10 mils. You're gonna add that to the salt water solution in your Erlenmeyer flask, and then you're gonna add another 5 mils. Boop. And you're gonna add that to your flask. So now you should have the 4.5 grams of salt and the 15 mils of water. Now what you're gonna do is you're gonna swirl this until the salt dissolves. Now one of the things that they mention in the preparation is to microwave this if it doesn't dissolve. I have yet to have a student not be able to get it dissolve at room temperature. One thing that you can do is, it will take a minute, it takes a little while, but one of the things that can really help facilitate this is, if you want, you can use your body temperature. So what I will sometimes do is I'll take this flask and I'll put it in my hand, close my hand around the solution and swirl. You can even put your thumb over the top to prevent spilling. Often just the temperature from your hand is enough heat to actually help facilitate this dissolving. So it's a pretty soluble mixture of salt and water, which means unlikely you're gonna need to use the microwave. And again, if we can avoid boiling hot salt water, that's something we wanna do. So again, you're gonna swirl and swirl and swirl. You can use the temperature from your hand to help facilitate the dissolving of that salt. Again, probably will take maybe 2 to 3 minutes of dissolving, but eventually what you'll end up with is a clear saltwater solution. So I didn't bore you completely. I went ahead and paused this while I swirled, but as you can see, after about 3 minutes of swirling using the temperature from my hand, I now have a clear solution of salt water. We're going to set that aside, and that's going to be used in the course of the rest of the experiments.